Now let's see the converse of the previous session. Today's session is about the converse connected with the angle properties in a parallelogram. The converse. So what is the converse of the angle property? Let's revisit the angle property as discussed in the previous session. In a parallelogram ABCD, if we have defined that the opposite angles are equal. Now comes the question, if in a quadrilateral the opposite angles are equal, will that be a parallelogram? Is how we understand the converse. So imagine I take a quadrilateral ABCD, which is not a parallelogram yet. I say my opposite angles, angle A and angle C, are equal, and my other set of opposite angles are equal, then this quadrilateral must form a parallelogram, is how the property defines. If the opposite angles in the quadrilateral ABCD are equal, then the four-sided closed figure formed, the quadrilateral thus formed with opposite angles being equal, must be a parallelogram, is how we understand the converse of the angle properties. So this equals this and this equals this. So the property says if opposite angles are equal in a quadrilateral, then the quadrilateral will form a parallelogram, is how I understand the property connecting the parallelogram with opposite angles. So if opposite angles are equal in a quadrilateral, then the quadrilateral will form a parallelogram. Therefore, for quadrilateral ABCD, which we have out here, if angle A equals angle C and angle B equals angle D, that is opposite angles are equal, then ABCD is a parallelogram. That is, ABCD will automatically have its opposite sides being parallel. With opposite angles equal, the quadrilateral shifts to be a parallelogram, is how we understand the learning outcome of the converse of angle properties in a parallelogram. Now that we have discussed about the angle properties in a parallelogram, now comes the question on how do we connect the properties of a parallelogram connected with its diagonals. Today's session is about the diagonals of a parallelogram connected with its own respective properties. Properties connecting the diagonal. Diagonal properties in parallelogram. Let's consider a parallelogram with its respective diagonals. So here I have a parallelogram A, B, C and D. So clearly we know that the opposite sides are parallel and of course equal. For this parallelogram we have two diagonals as discussed in the previous session. So one of the diagonal is obtained by joining AC and the other diagonal is obtained when I join BD. So here my diagonals are AC and BD are the diagonals. Now let's see what is the property which connects these two diagonals. Before this, I clearly understand that diagonal AC intersects diagonal BD at say some point M. So I clearly have a point of intersection of the two diagonals as represented by M. So here my M is the point of intersection of the two diagonals. So M is the point of intersection of the two diagonals, diagonal AC and diagonal BD. So let's see the property connecting the diagonal property. The property says that the diagonals AC and BD bisect each other in a parallelogram. This is one of the most important property in the parallelograms because bisecting concept helps us in solving many mathematical problems. To come with the property, diagonals bisect each other in a parallelogram. What do we mean by bisect? The word bisect means cutting at midpoint. That means the diagonal AC, say the midpoint or the middle point exactly of the distance A and C is M, then clearly the middle point of BD is also said to be M. It's how we understand bisecting each other. Bisecting each other in the sense the midpoint of AC must be the same as midpoint of the other diagonal BD. So therefore, when the point of intersection is this, I understand this equals this and this equals this. Is how the bisection is understood in parallelogram concept. Diagonals bisect each other in a parallelogram. Therefore, AC and BD bisect at point M. That is, M is the common midpoint for the diagonal AC and the diagonal BD. Is how we understand the bisection. And using this property, M bisects AC and BD. That is, more simpler understanding, M is the common midpoint for the diagonals AC and BD. Is how we understand the diagonals bisecting each other. Diagonal property, diagonals in a parallelogram bisect each other, is how we understand through the parallelogram A, B, C, D. Now that we have discussed about the diagonal property in a parallelogram, now comes the discussion of converse. Will the converse be true? That is, if the diagonals in a quadrilateral bisect each other, will the quadrilateral form a parallelogram? It's the biggest question in converse. So let's investigate the converse of the session. Diagonal property. parallelogram converse. So let's see the converse of the previous session. Imagine I take a quadrilateral A, B, C and D. So I have a quadrilateral formed by 4 lines in the closed region A, B, C and D. Let's see the property connecting the converse. Now imagine I take the 2 lines joining AC and BD out here. Now if the diagonals bisect, that is, if the diagonals meet at the common midpoint, then will this shape be a parallelogram? Yes, it will be. That is, the converse holds for a quadrilateral where the diagonals bisect each other. So let's see the statement of converse. The converse statement says, if the diagonals of a quadrilateral bisect each other, then the quadrilateral will form a parallelogram. Yes, the converse of the previous session holds. If the diagonals of a quadrilateral bisect each other, then the quadrilateral must form a parallelogram. They must form the pair of lines which are parallel to each other, is how I understand the converse of the previous session. Therefore, in this case, M bisects the diagonals AC and BD, implies M is the common midpoint of the diagonals AC and BD, and that implies quadrilateral ABCD reduces or forms a pair of parallel lines. Quadrilateral ABCD forms a pair of parallel lines, this being parallel to this and this being parallel to this. Therefore, quadrilateral ABCD is now called a parallelogram. Now I can call my quadrilateral ABCD to be a parallelogram. Therefore, the converse, if the diagonals of a quadrilateral bisect each other, then the quadrilateral must be a parallelogram, is how we understand the concept connecting the converse. Now that we have defined about the quadrilateral and its different types of quadrilaterals, the most important of them being parallelogram, and various other quadrilaterals like square, rectangle, trapezium, rhombus, kite, etc. The most specific quadrilateral which we have discussed in the previous session and its varied properties was parallelogram. So let's see the other definition of how a quadrilateral can be defined to be a parallelogram, or how a parallelogram is defined, or when the quadrilateral becomes a parallelogram. So these are related to the property, another condition for quadrilateral to be a parallelogram. other condition for a quadrilateral to be a parallelogram. So let's see the other condition. Now that we have defined the quadrilateral to be a parallelogram if its opposite base or if the pair of sides of the opposite sides are parallel, then the quadrilateral becomes a parallelogram. Now let's define the other condition for a quadrilateral to become a parallelogram. So coming out with the definition, when the opposite sides are parallel, is how we have taken for line 1, line 2, line 3 and line 4 arranged in such a manner that it forms a closed region with its opposite base being equal is said to be a parallelogram. Now we will try to change the definition into a more modified form. Let's see the definition, which stands for another condition for a quadrilateral to be a parallelogram. A quadrilateral definition. A quadrilateral is said to be a parallelogram if its opposite sides are parallel and equal. This is said to be the modified form of defining a quadrilateral to be a parallelogram. So a closed four-sided figure that is a quadrilateral is said to be a parallelogram if its opposite sides are both parallel and equal, is how we can combine the parallelity and equality for making a parallelogram or defining a parallelogram. So ABCD is a parallelogram if quadrilateral ABCD is a parallelogram if AB is parallel to DC, and AD parallel to BC. AD parallel to BC. Along with this, it must also satisfy the equality condition. This becomes parallelity condition, and the equality condition is that AB must be equal to DC and AD equals BC. Is how I understand a quadrilateral ABCD reducing to a parallelogram if it satisfies the parallelity condition. Parallelity and equality condition is how I understand a quadrilateral reducing to a parallelogram as another condition for a quadrilateral to be a parallelogram. The quadrilateral is said to be a parallelogram if its opposite sides are parallel and equal. is how we understand the definition for quadrilateral reducing to a parallelogram. Now that we have defined a parallelogram and a rectangle as the special cases of the quadrilateral, let's see how a rectangle can be derived from a parallelogram. There's an interesting property which connects deriving a rectangle from a given parallelogram. Today's session is about deriving a rectangle out of the parallelogram. So let's take a parallelogram ABCD. Deriving a rectangle from a parallelogram. So let's see how a rectangle is derived from a parallelogram ABCD. So here is the parallelogram ABCD. Of course, the pair of sides being parallel and equal. Now, the two sides are parallel and opposite sides are equal. Now let's see how a rectangle is derived. Now as I have four angles, angle A, angle B, angle C and angle D. Now here I would like to draw a bisector for each angle. That is, for angle A, I take the bisector that is exactly at equal angle. I just extend this. Similarly, I take the bisector of angle D. Angle B. So here is the bisector of angle B, exactly cutting at equal angle. So here is the bisector for angle B and here is the bisector for angle A. Similarly, I have a bisector for D which I derive out here, and a bisector at C derived out here. So I have taken for each angle of a parallelogram a bisector, that is a line which makes equal angles on either side is what we call the bisector. So here I take a line which makes equal angles on either side. I take another line which makes equal angles on the other side, similarly at C and D. Interestingly, I see that each of the lines, line 1 and here is line 2 and here is line 3 and here is line 4. So these four lines try to intersect at four different points and it forms a region which is this. It forms a region which let me denote by PQRS. Now this region seems to look like a four-sided closed figure. Yes, the four lines, line 1, line 2, line 3 and line 4 intersect to form a four-sided closed region, and which is called a rectangle. The bisectors of a parallelogram intersect to form a rectangle. It will have each angle is 90 and opposite sides are equal, is how I see the property for this. So PQRS quadrilateral PQRS, which is formed by the bisectors of the original parallelogram. Usually this quadrilateral is formed by the bisectors of each of the angle of the parallelogram, which is formed by the bisectors of by the bisectors of each vertex A, B, C, D. Each vertex of the parallelogram ABCD is a rectangle. Is how I understand the property. The quadrilateral PQRS, which is formed by the bisector 1, bisector 2, bisector 3 and bisector 4, forms a close-sided region which is called a rectangle. Is how the property comes. Therefore, PQRS is a rectangle and each of the angles is 90 and opposite sides are equal. Is how we understand the concept of the rectangle derived from a parallelogram. So any parallelogram whose bisectors are meet at 4 different points, that 4 close-sided region is called a rectangle. This holds for any parallelogram existing in the branch of mathematics. Rectangle derived from a parallelogram. Now that we have discussed about triangles and quadrilaterals with their varied properties, now comes the most important theorem in the topic of quadrilaterals or in the topic of triangles, called Midpoint Theorem. So let's see what a midpoint theorem is. Midpoint Theorem. So what is a midpoint theorem? As a theorem itself clearly says midpoint, therefore I see that this theorem is related to a midpoint taken on a line segment. We all know what a midpoint is. Just to recap, if I take a line segment AB, then exactly the middle point, which is exactly in the middle of A and B, is called midpoint. So in case of this line segment, this equals this and M is called midpoint of line segment AB. Is how we understand the midpoint of a line AB. Here is M, exactly in the middle. So let's see the midpoint theorem in brief. So let's derive the statement before we come to the understanding of midpoint theorem. The statement. The statement says the line joining the midpoints of any two sides, the line joining the midpoints of any two sides of a triangle is parallel to the third side. Is how we define a midpoint theorem. So midpoint theorem states the line joining the midpoints of any two sides of a triangle is parallel to the third side. So let's see the statement in brief. Now this whole theorem is related to a triangle. So let me take a triangle ABC. So here is the triangle A, B and C. Now the theorem says the line joining the midpoints of any two sides of a triangle. So let me take the midpoints of any two sides and then connect the two midpoints so that I get a line. is how I understand the first part of the statement of the theorem. So here, let me take the midpoint of AB, which is, say, denoted by D. And let me take the midpoint of AC at E. Just like the midpoint of AB here is M, which is exactly in the middle, same way D is exactly in the middle of AB and the point E is exactly in the middle of AC. Now, let me join the line DE. So I have a line segment connecting the two midpoints D and E. So the line referred here is nothing but the line DE in the diagram of triangle ABC. Now it says that the line which joins the midpoints of any two sides of a triangle, in this case being DE, is parallel to the third side. Midpoint theorem says such a line which exists connecting the two midpoints must be parallel to the third side. Is how we understand the midpoint theorem. So midpoint theorem connected with two midpoint lines are parallel to the third side. So here DE is parallel to BC. Let D be midpoint of AB and E be midpoint of AC. Of AC. Now the next step is that I join DE. So once I get DE, now the midpoint theorem says midpoint theorem says that DE is parallel to BC. Is how I understand the midpoint theorem. The line joining the midpoints of any two sides of a triangle is parallel to the third side. It need not be the midpoints of these two sides. If I take the midpoints of these two sides, then that line must be parallel to this. If I take the midpoints of these two sides, then the line joining the midpoints must be parallel to this side. Is how I understand through the statement of midpoint theorem. Midpoint theorem connects the parallel lines with the midpoint concept. Now that we have defined the midpoint theorem connected with the parallelity of the two midpoints joined for the two sides of a triangle, now let's see the extension of the midpoint theorem. There is an extended property which relates to the midpoint theorem. So let's see the extension of midpoint theorem. Extension. So the extension of midpoint theorem says that, before that, let's recap with the midpoint theorem. Now the midpoint theorem says if I take a triangle A, B, C and I connect the midpoints, midpoint of AB being D and midpoint of AC being E, then the line which joins the two midpoints, we know that it is parallel to this. That's how we have understood midpoint theorem in the previous session. Now with this parallelity, let's see the extension property of midpoint theorem. So along with DE being parallel to BC, by midpoint theorem, DE is parallel to BC. But the extension property says that the length DE will exactly be half of the length of the third side BC. So let's see the extension mathematically. Extension of midpoint theorem says that length of the line segment DE is exactly half of the length of its third side, which is BC. So this length must be half of this. If this is 12 centimeters, this must be 6 centimeters. If this is 7 centimeters, this must be 3.5 centimeters. Is how we understand the midpoint theorem connected with the extension. So here simply I can write this as DE is half BC, or I can also write this as BC is twice of DE. Is how I understand the extension. So my theorem for extension says if a line joining the midpoints of two sides of a triangle is parallel to third side and also is exactly half of the third side. So my statement goes like this. The line joining the midpoints of any two sides the line joining the midpoints of any two sides of a triangle is parallel to the third side and exactly half of it, This is what defines the extension of the midpoint theorem. So now proudly I can define or state the midpoint theorem as the line joining the midpoints of any two sides of a triangle is parallel to the third side and exactly half of it. Is how we can relate the midpoint theorem completely in its own understanding. So the statement is how we define midpoint theorem and its extension connected with midpoints and parallelity. Now that we have discussed about the midpoint theorem and its extension connected with parallelity and the midpoints, let's see if the converse of the same theorem holds. So let's see today's session about converse of midpoint theorem. That is, if the line passes through the midpoint and is parallel to the third side, will the other point be also the midpoint, or will the other point bisect the third side? Is how we understand the converse. That is, a line which passes through one of the midpoint and parallel to the third side, when it cuts the other side, will this cut the midpoint? Is how we have to understand the converse. So we are investigating if this line passing through the midpoint of this side and parallel to the third side passes through the midpoint, exactly passes through the midpoint of the other side, or if it passes through the other point, is what we are going to investigate in the converse of midpoint theorem. Converse of the midpoint theorem with its statement. Converse of midpoint theorem. So let's make the statement. The line passing through the midpoint of one side of a triangle. So a line passing through midpoint of one side of a triangle. Midpoint of one side of a triangle and which is parallel, say, and which is parallel to the other side, and which is parallel to the other side, must bisect the third side. That is, this comes out to be the third side, and this line, which is parallel, must pass through the midpoint of the third side. There's no other way. The line cannot escape the midpoint, is how the converse states. And which is parallel to the other side must bisect or must pass through the midpoint, the third side. That is, it must pass through the midpoint of the third side. No escape. Is how we understand the midpoint theorem. So let's see the midpoint theorem in its converse. ABC is a triangle. Let D be the midpoint of AB. Then a line which passes through this midpoint and which is parallel to the third side. So here, let D be midpoint of AB. And let me extend this line to be some F, and DF parallel to BC. Then in this case, then converse of midpoint theorem states that the converse of midpoint theorem under these two conditions states that DF passes through the midpoint. Say this is the midpoint E of AC. Then the converse of midpoint theorem states that the line DF or the ray DF passes through the midpoint E of AC. Is how I understand the midpoint theorem in its converse. Converse of midpoint theorem, which says the ray passes through the midpoint. So we have both the midpoint theorem and its converse both being equally true. That is, when a line passes through two midpoints out here, then that line must be parallel to the third side, and in case the line passes through one of the midpoint and is parallel to the third side, also that line obviously must pass through the other midpoint. Is how the midpoint theorem and the converse of midpoint theorem both hold equally true in the branch of mathematics. Midpoint theorem and converse of midpoint theorem. Now that we have discussed about the midpoint theorem and its converse, now the question comes on applications of midpoint theorem. So today's session is about applications of midpoint theorem in the branch of mathematics in solving of math problems. So let's see the applications in brief. Applications. So let's see the applications of midpoint theorem. Here I have a question which says, find the area of the following triangle whose altitude is 4 centimeters. Now here I have a question which says about finding the area of the triangle whose altitude or the height is given to be 4 centimeters. So let's take the triangle. Here is the given triangle. The question says D is the midpoint and E is the midpoint and ABC is a triangle such that the distance between AB is, say my altitude is, let me take 12 centimeters and this be 4 centimeters. That's how, or I take this to be 5 centimeters is what is given. Now my question is about finding area of this complete triangle. So let's see how I can find area of this triangle using the concept of midpoint theorem. Midpoint theorem and its application in solving math problems. So let's take the given information. Now altitude is given to be 12 centimeter, that is my altitude which drops as perpendicular from here. Let me take this to be AL. My altitude is the perpendicular or the height in the triangle. My AL in triangle ABC, the given things are the altitude AL is given to be 12 centimeters and my DE, the distance between midpoints, DE, distance between midpoints, DE is given to be 5 centimeters. Now the question is about finding the area of this triangle. So I have my base, I have my height, but the dimensions of the height is given to be 5 centimeters, but the dimensions of the base are not given. So my target out here is to find the dimensions of the base, that is the length BC of the triangle ABC. So how do I find the dimensions of the base? Let's see how we can do using midpoint theorem. Now here, by using midpoint theorem, in my triangle ABC, my BC is twice of DE, or I have my BC is twice of DE. This is strictly from the extension of the midpoint theorem, as we have seen in the previous session. So when the line joins the midpoints of two sides of triangle, then this is exactly half of this, and of course parallel to this. Is how we have seen the midpoint theorem in a statement. Therefore, my BC is twice of DE, which is already given to be 5 centimeters. So DE equals 5 centimeters is substituted in place of DE. So which comes out to be 10 centimeters. Therefore, I have my length of BC, which is 10 centimeters. My BC is 10 and my AL is 5. So let's utilize. Therefore, length of BC is 10 centimeters and length of AL is 12 centimeters as given in the question. The altitude is 12 centimeters. Therefore, in order to find area of triangle, we know that area of triangle is half into base into height. Therefore, my base is this and my height is this. So this is the base and this is the height. And therefore, area of triangle ABC would be half times base times height. Therefore, using the formula for area of triangle, ABC is half times base times height. Half into base into height. In this case, half times my base is 10 and my height is 12, which on further simplification gives 12 5s, 2 1s 2 5s, 12 5 60 centimeters square. Therefore, area of triangle ABC, whose altitude is 12 centimeters and the distance between the midpoints D and E is 5 centimeters, is on the whole 60 centimeter square. Is how I can find the area using the midpoint theorem. Given the altitude and the distance between midpoints, I can find the length or the dimension of the third side using the midpoint distance, using the midpoint theorem and its extension. So midpoint theorem helps us in finding base and height, and hence the area, which is 60 centimeter square. Area of triangle found using midpoint theorem. Applications of midpoint theorem in finding areas of triangles.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.